Oh, hang on, guys. We're not seeing John on our video here. Give me a second. Let me just double check. We got him pulled up here. Nope. One second, guys. All right, John's back. Sorry, guys, a little technical difficulty there. And we're here. We're live and we're here. And should be all good to go. Sorry about that little technical difficulty there. Hey, John, how are you?
I'm great, man. How are you, Simon?
I'm doing good. Doing pretty good, you know, working as usual, but I'm happy to be on this Lunch and Learn and kind of showing you guys our process here and teaching you guys some new stuff.
All right. Well, let's get started. I better go 3, 2, 1, and welcome. Welcome to the HSC live Lunch and Learn here every Tuesday at noon Eastern Standard Time. My name's John Gross, one of your commercial drone sales advisors here at HSC, and I have Simon, our lead tech, with us today.
Hi, guys.
There he is. And I think I might have froze. I don't know, because I don't look like I'm very happy with the.
Yeah, we can hear you fine, but it does look like you froze. Oh, there, you're back. I think my internet connection here might be a little. All right. On
guys,
off.
We'll work with that. Sorry about that, but don't forget to like this if you like this stream, and we've been doing it now for 3 or 4 weeks. We're going to keep it going. If you have questions, feel free to throw it in the chat. I'm going to keep an eye on that and monitor that while Simon's talking to us today. But today we're going to talk about spraying drone operations. So here at HSC, we've been, selling drones for over 10 years, but in the spraying drone market for over 7 years now. So we've got an awesome, what we think is probably the best drone on the market. We're biased. We'll talk more about that. But what we really wanted to go over today was, sharing knowledge and education around actually the operations of a spraying drone. So there's a lot of things that kind of go into it that people really don't think about. And we will, dive into that with our checklist. So if you have questions, like I said, throw them in the chat. I'll try and field those as we go, interject with Simon where it makes sense so we don't derail him. But at the same time, we will open it up at the end for sure. So if there's any other topics about drones that you want us to chat about, by all means, throw it in there. And if we can't get to it today, it may be a topic for next week or the week after. So with no further ado, Simon, please take it away and I'll sit back and help you out.
Absolutely. Thank you, John, for introducing us. And thank you guys, the viewers, for joining us today. Like John mentioned, we do these Lunch and Learns for you guys. We'd love to hear your feedback and questions regarding our Lunch and Learns. And like John said, please post any questions or comments in the chat box to your right there. It really helps us in the future for other Lunch and Learns really be able to answer your questions directly. So thanks again, guys, for joining us. But let's go ahead and move on. Like John mentioned, today we're going to be discussing spray drone operations. So we're really starting from the initial stages of spray drone operations all the way to the end. So essentially our workflow and what we do in order to operate our spraying drones. And I think there's a lot of misconceptions as to how these spraying drones are used. So hopefully we can clear some of those up today. So let me just move on to my next scene here. And let me pull up my web page with this. Okay, so this is our AG 122 model. This is our largest model that we offer. It's a 6-gallon spray drone. And we're going to discuss this model, but all of our AG models essentially have the same workflow with a couple of minor differences in the checklist and how the batteries are laid out. But all 3 models use the same software. They use the same steps, essentially. So I do want to mention that between all 3 models, the 110, the 116, and the 122, really the biggest difference is simply the size of the aircraft. The operations of the aircraft remain essentially the same throughout. So let me go ahead and switch over to one of our documents here, and give me just a sec here to switch this page over to this page right here. So this document is actually a page out of our manual. And first of all, let me start with saying I really, really like the way the Helio operations manuals are written out. They're really straightforward, really self-explanatory, and you can clearly tell there's a lot of time spent into making this as easy as possible to understand. So let me go ahead and pull up here. Oh, John, are you having some issues with your light?
I'm sorry. I'm feeling like
no, it's all right.
I'm just trying to make it better for
perfect.
everybody.
There you go.
Yeah. Okay.
Awesome. Sorry. Hey, this is why we do this live. We're not trying to hide anything from you guys. This is as raw and real as it gets.
It's nerve-wracking at times, man.
Sometimes it is, yeah. And there's, even though we've been doing this for a couple weeks now, there's always little hiccups here and there, but,
Sorry.
No, it's all right. Like you saw my screen wasn't working earlier, so that's totally on me. So we're always learning. We're always trying to improve our demos and our lunch and learns, and hopefully you guys... again, if there's any feedback, if you guys have any issues with the quality or audio or anything like that, let us know, because we're always here to improve. Anyway, moving on, let's go to our operations manual here, right here, this page here. So this is the system operation manual. Let me just double check that you guys can still see it. All right, awesome. So this page shows the PreMission workflow of our drones, and basically the steps that you need to take from the very beginning to the very end with your spraying drone. So I love this page in the manual because it really gives you a kind of a top-down view of spraying drone operations. Super cool. So PreMission workflow, step 1 is your survey. Your survey starts with traveling to the mission area before the scheduled operation. So the first thing we do is we want to know where we plan to operate these drones. The second step is to locate any fields that will need to be treated. So here we're locating any fields that need to be treated, locating any specific areas that need to be treated, and we're surveying those fields for any dangerous topography, obstacles, nearby residences, and any other criteria that could potentially disqualify the field for UAS operations. So let's discuss that step a little bit. All of our spraying drones have a obstacle avoidance sensors and a radar terrain sensor as well. So what that means is the drone will automatically follow changes in topography and maintain its distance evenly across changes in grade and terrain. The obstacle avoidance sensors will also detect any obstacles that could potentially be within its path. Now, backing up a little bit, the obstacle avoidance sensors are there as a safety device. Typically, we don't recommend relying on the obstacle avoidance sensors to avoid obstacles because we plan for our obstacles ahead of time in our spray mission. So that
yes, I get that question a lot.
Yes, exactly.
And then, since you're here, I'd like for you to answer what happens when that obstacle sensor goes off and why it's important to put the obstacles in.
Exactly. So if we set up an obstacle in our spray mission, in our flight plan, the drone will automatically plan to fly around those obstacles. It's going to automatically turn on and off the pump while it flies around those obstacles. And essentially, you don't even need to worry about the obstacles if you plan them ahead of time. Now, let's say there's an obstacle that was missed or you didn't plan for obstacles ahead of time. What will happen is the obstacle avoidance radar sensors will detect that obstacles as the drone approaches the obstacle. Once it gets to a certain distance from the obstacle, and it is an adjustable distance, we can discuss that a little bit more later, but once it gets too close to the obstacle, the aircraft is simply going to stop and hover. When it does that, it's also going to shut off the spray pump. So what will happen is, if it detects the obstacle, it's going to stop and hover, and it's going to wait for an input to fly around an obstacle. So this isn't a very efficient way of operating, because if you're always relying on the obstacle avoidance sensors, it's going to rely on a human input to tell it to go around an obstacles or to a different location.
Because I like to tell at that point in the conversation, I just explained the simple fact that, these things are super advanced and super complex, and we can tell them to do about anything we need them to do. So a lot of people are like, can it do this? Can it do that? And the answer usually is like, yes, yes, yes. But, that important point is you need to plan, like you said, for these obstacles, because it's not artificial intelligence. And so that's what I'll say. I'll be like, I'm sorry, it's, they're really complex, but it's not AI. So you need to plan for it so it knows how to go around it. And also it might be way off in the distance, getting to that to see what to do next might be very difficult.
Right. And the reality right now is, although artificial intelligence, it does exist to allow aircraft to fly automatically around obstacles, it's just the baby stages right now. And from our experience, it's just not that reliable. It's not reliable to the point right now where you can just send it off with trees everywhere in the way and have it automatically fly around it. Not only is it not reliable, it's also not efficient. It's always more efficient to plan obstacles ahead of time. So that's why we always plan for obstacles. Now, the beauty of having the obstacle avoidance sensors is if you do make a mistake or you don't put an obstacle in and you forget about one, it's not like the drone's going to fly right into it. Of course, it's going to stop ahead of time and keep the aircraft safe. And that's really the key. I always equate it similarly to a lot of modern cars. They have automatic braking in case something jumps in front of it, or if the driver's not paying attention, it will stop for you. But you probably wouldn't rely on your collision detection in a car to stop for you all the time. You wouldn't drive with your foot on the gas pedal all the time. That's how I equate it. And I think about it the same way on the drone. You always need to plan for that ahead of time. And really with not just spraying drones, but all drones that have automated mission planning, the surveying and the mission planning and creating the mission is really where all the work is. Because once it's created, there's one button that you have to push, essentially. You tell it to take off, the whole drone does the entire operation automatically. So the mission planning is kind of the key aspect of automation in drones. It really is.
Absolutely. And that's kind of what we're discussing today, is that whole, workflow, mission planning / operating the drone. So guys, if you have any questions, please throw them in the chat as we work through this.
Right. Okay. So step 4 here, and this is actually an option, but you can use your GPS tracker to safely mark flags and obstacles in all application areas.
Step 4? Can you scroll some? Because I'm seeing step 2.
Oh, hang on. Let me double check. No problem. Let me scroll down a little bit more. Are you able to see that now?
Not quite. It still says step 3 behind your head.
Oh, I'm sorry. It's number 3 in step 1. My apologies.
Okay.
My apologies. I'm looking at step 1, and we're actually on number 4 right here.
Step 1.4. Okay.
Yep. We haven't gotten to step 3 yet.
I was wondering, like, how did we jump through step 2 and 3?
My apologies. Yeah, I didn't mean to confuse you guys there. Thank you for bringing that up, though. So,
well, I get confused easily.
Yeah. So we're right here. I'll highlight it. We'll use our GPS tracker to safely mark flags and obstacles in all application areas. So this step is not required if the field is previously marked or you're using an imported shapefile that is deemed safe. So let me explain this step real quick. All of our Helio model spraying drones include basically a handheld GPS tracker that can connect to your PC device with your ground station, and it allows you to actually walk your field or in a vehicle, drive your field and actually mark flags and obstacles using an actual GPS. This is our preferred method because it's really the safest way to create your survey mission, especially if for any reason the area that you're flying in doesn't have good map data. This gives you an actual boots on the ground location of anywhere in that field area. Again, this step is not required if the field has already been previously marked or if you're using a shapefile or a KML file that's been imported. So there's a lot of different ways that you can generate an area. Again, you can use the GPS tracker. You can import a shapefile. You can import a KML file. Or if you trust your Google Map data, which is typically what we use, and it's actually very accurate, and you don't have too many obstacles in your way, you can simply use your Google Maps data within Agrosol to create your boundary in your area.
And we actually have used that, with our own drone. We've driven around, right, and we've marked it. So personally, like, we know how. It's pretty easy, and like you said, it's the most accurate way to do it for sure.
It is.
You could do it on an ATV, depending on your farm. You don't have to be in a vehicle, but it's really easy to use.
And again, if for your application or your field, you already have a shapefile, you can just import that, because that's already created using essentially the same method. So you don't have to do double work. It makes it a lot easier. So you also want to confirm that any obstacles within the area are safely marked. Again, you can use a tracker or other methods. And you would determine the chemical and rate for the application of those properties. Again, this is all in step one. This is your survey. This is before you even need to bring the drone to that field.
Mm-hmm.
Now we're moving to step two, and these are our pre-mission preparation steps, okay? So the first step would be to draw your shape files in Agrosol. So again, these would be based on the methods that we described a second ago, either a shapefile, a KML file, a GPS tracker marks, whatever it may be, or if you have another drone that you use to survey that field and then you're using that data to create a shapefile. There's a lot of different ways that you can create missions, and we've discussed that a little bit in the past. And again, if you guys do have any questions about that, please put them in the comments below. You would create your mission shapefiles. Then we can calculate our chemical ratio that we use in the application. So typically here, we would actually determine how many gallons per acre are we applying, right? And the next step here, number 3, select safe mission speed and altitude for the area, also correlate to the chemical ratio, because for the application rates on drones, typically directly correlate to the safe mission speed as well.
And Simon, can we talk about, on average, what we see that to be when we're out doing our demos? Because I get that question a lot.
Sure,
how fast does a drone fly? And I think what they're asking is, like, on average, like, what does it fly? And I think we could probably answer that.
Yeah, so let's take, for example, a 2 gallon per acre rate. I know from experience on our 122 that I happen to have sitting right in front of you from our last training that we did last week. By the way, we do training every month and flight demos every month. If you're interested, check out our events calendar on our website, hse-uav.com. But say a 2 gallon per acre rate on the 122 model, we typically fly around 8 to 10 miles per hour.
Okay.
Okay. The drone can fly faster than that. So if you're running a lower rate, it's possible to fly a little bit faster. Maybe at a 1 gallon per acre rate, we might be able to go 12 to 14 miles per hour. And we'd have to do some calculations. There's a calculator built into Agrosol to determine essentially the maximum speed that you could fly while still being able to apply what you ask it to apply. So,
in a crazy low application rate, though, like, the drone could fly up to what, 20?
Yeah, I believe the maximum speed on all 3 spraying models is about 20 miles per hour.
Yeah, and that would be insane if you had like a half a gallon spray rate and you could fly at that speed.
Right. And really the bottom line is, with any spraying drones, the lower you can get your spray rate, the more efficient it is. Right. The faster you can fly. The drone can only output so much from its spray pumps. Like on the 122 model, I believe it's about 1.2 gallons per minute, if I'm not mistaken. You can find the specs on our website, but that's about what we can expect. And, with a low application rate, we can really bump the speed up significantly.
Yeah, absolutely. Cool. All right. What's the next step in this, spraying drone operation checklist that we have here?
Sure. Yeah. So the next step would be to make sure all your flight batteries are charged and ready to go. This includes the drone batteries, but also your controller batteries, your ground station computer batteries, any kind of camera batteries you might have, any type of batteries that you might need to charge ahead of time. I always like to start my operation with everything 100% charged, right? You don't want to be guessing or having your controller die halfway through your flight or anything like that. So that's actually part of our checklist too, is to ensure that all of the batteries are fully charged.
Yep.
And again, this next step is kind of related to that. Confirm all required operational equipment is accounted for and in good condition, of course.
Okay.
The last thing you want to do is get to your flying field and realize you forgot to bring your charger. I speak from experience.
Or an adapter, right? Or some type of weird adapter that
right,
goes from one thing to
your,
another. Who knows?
Or your data radio, or something critical to your operations. You know, you don't want to potentially drive 2 hours out of your way to get to your flying field and forget something. So I actually have, like for my training, for example, I have a checklist of everything that I need to bring to the field. Because, like I said, I speak from experience. Don't want to be me. So let's move on. Let's scroll down just a touch here. So finally, well, not quite finally, but step 3 is our spray missions. And our spray missions involve traveling to the spray area. And then we would want to unload the drone in a safe location and as close as possible to the application area. This is going to reduce ferry time and improve efficiency. So let's talk about that real quick. When it's possible, we always want to take off as close as possible to where our mission starts. The reason being is when we're taking off, we have a full payload on the aircraft. What's interesting about spraying drones is that the payload varies as the aircraft flies. So as it's flying, it's getting lighter. But at the beginning of your flight is at its heaviest point. And if you're not starting your mission close to where you're taking off, you may need to travel a quarter of a mile to your start location. And it's not like it's going to start spraying and emptying the tank while it's traveling to that start location. So it's flying with the heaviest possible payload. So if your ferry distance is far, it's really going to take a toll on your battery life. So it's always best to have the starting position for your mission as close as possible to your takeoff location.
I mean, that makes sense, right? And then what about like on landing? You could, you could potentially have it land down the line, right? Save battery. And then if you had a spraying truck with your chemical, move on. I guess it depends on your location. There's all different ways you could do that, but I know our software allows you to land in different spots.
Right. Great point. So yeah, we can choose to land where we took off from, and in a lot of cases, that's what we do. Or if we have a very large operation or a very large field, we can actually land, for example, on the opposite side of the field and actually move our operation to then start from its new landing point, so that we're not having to ferry the aircraft all the way across the field on our next operation, which could be starting on the opposite side. So that's a great point.
Awesome.
So next step will be notify the property owners that the UAS operation will commence. I always like to notify any bystanders or any what we call non-participants that were operating an unmanned aircraft. It's interesting, I'm sure you know, John, these aircrafts, they bring a lot of attention, Yeah,
I mean, even a small one.
Even a little one.
A small camera drone that you take out, like they bring attention. So imagine.
But especially a big one.
30-inch blades.
Yeah.
They 20 liters of chemicals. They're like, what in the world are you doing?
They tend to be a showstopper. So, in my operations, I do always like to have a VO or a visual observer to assist operating this drone. And maybe you're near a public roadway and you'll have people just stop in the middle of the road and start asking you questions. And as a pilot, I can't have those kinds of distractions. So, having a visual observer is always helpful to kind of assist with that kind of stuff and really manage all the ground operations, because we have a lot of batteries and tanks that need to be swapped out and charged. But so then we'll begin our spray operations. We'll follow all our pre-flight checks. We have pre-flight checklists for all of our aircraft. We'll follow all UAS and chemical safety guidelines, of course. This is the easy part. Once we have all our mission planned, all we're doing is telling it to arm and take off. The drone is going to handle everything else from after it takes off to its whole spray mission, all the way back to its landing. Of course, after its completion, we'll notify the property owner. We'll follow our rinse procedure on our spray systems and pack up. We'll follow any safety guidelines for equipment transportation, and basically move on to step 4, which is our daily maintenance checklist. So let me scroll down just a little bit more here. So essentially, we'll just follow our daily maintenance checklist. This is a separate checklist from our pre-flight checklist. I'll show you guys both of these quickly in a minute. I know we're kind of running close on time here, but I'll show you quickly. But after we follow our daily maintenance checklist, which essentially consists of cleaning the aircraft, checking any components on the aircraft, we would upload our flight logs whenever possible.
Cleaning the aircraft, though, real quick.
Yeah.
Our aircraft can pretty much be hosed down.
Right.
Right. Forget what rating that is, but in terms of cleaning the aircraft for ours, it's pretty easy.
Right. And to be honest, this is a question I get all the time. I get asked, well, when I'm done operating it, I can just pressure wash or hose off my drone, right? Well, you probably can, but realistically, it won't be necessary. You'd be shocked how little chemical ends up on the drone. That prop wash really pushes everything away from it. And from our experience, and we've been, doing a lot of testing with UV dyes on this aircraft, the thing is spotless, even after spraying UV dye that gets absolutely everywhere. If you guys know what I'm talking about, and we barely have anything on the drone. I mean, maybe a couple little drops here and there if it's a little windy. That's about it. Really, all it takes is a damp rag and you just wipe it down. You shouldn't need to do much more than that.
Awesome.
Like you mentioned, it's you could hose it off, but it's really just not necessary to do so in most cases.
That's what happens to the drone.
Yeah, I mean, maybe if you're flying in a rainstorm, if you land in mud or something, but those are things that you can avoid easily.
Well, you never know. Emergency landings happen.
Yeah, it's possible.
But anyway, so clean it off, make sure it's in good shape. And the good thing about our drones, as you mentioned, is a nice damp rag. It's a nice, easy day at the field, right?
Exactly. Yeah. It's the post-flight operations on this are super easy. Really, you just want to make sure your system is rinsed properly. We typically follow a triple rinse procedure, but really you should follow the guidelines on the label of the product. I usually would recommend how to clean it. And then we basically ensure all our equipment is stored safely and follow storage safety guidelines for your products. The whole operation is really simple, guys. As you saw, most of the operation is actually in our pre-flight survey operations, which is up here. So this is really where most of our time is taken before we operate the aircraft, is actually setting up our missions. So I'll just really quickly, I know we only have a couple minutes left here. I just want to show you guys kind of what is included with these systems. This is a daily maintenance checklist. This goes through all of the procedures for basically end of the day maintenance. So you'll see we have cleaning steps. You have procedures for each part of the aircraft for cleaning. We have hardware maintenance checks. We have agrosol maintenance checks. So this involves basically downloading the logs, performing compass calibrations, etc. It's very, very simple. We also have our pre-flight checklist right here. So we have a spot for our PIC, our pilot in command, our VO, our visual observer, date, time, drone. And this goes basically through each of the steps of the drone before you can actually fly and take off. So it's a very straightforward checklist. Some of our previous systems, the checklists are pretty involved. But these new systems, there's so much less human input required on them that the checklists become a lot easier. So again, I think I want to go ahead and close it out there. We're right around 30 minutes. Again, what we discussed was related to the 122, which you can see in the background right here. But again, guys, if you have any other questions, you can put them in the comments below. Just make sure to like and subscribe the video. That really helps us out, and it'll notify you for our next Lunch and Learn, which will be hosted on Tuesdays at noon Eastern time. We also have live YouTube demos and in-person demos. You can check them out on our website in our events calendar. Right here at the top right, you can find our events page. And if you click on that, you'll find our events calendar. If you take a look at the month of March, you'll find the live virtual demo will occur on March 5th. The in-person demo is at the same, half an hour afterwards on the 5th as well. And then our next training classes too, which will be the 18th through 19th of March. So super excited for you guys to check that out. And I think we'll go ahead and close it out there. John, anything else you want to add?
Yeah. No questions in the chat, but I just wanted to mention like 2 extra points about the training since, we went through spraying drone operations and that checklist. Like we do go through that in training, but even in more depth, I just wanted to touch on how we help teach you, things like dialing in your drone. I use
Right.
that term a lot, and that basically means, based on what you're trying to spray, what micron size you need, right? Like we teach you that process to make sure when you get out there in the field, you know how to get your drone dialed in for your application. That's a really important part of training that we cannot cover in 25 minutes. It
No.
takes some time. And then also one other thing that like a lot of people don't even realize with these drones, and we teach you in training, is things like, and I'm not going to go into too much detail, but priming the pumps and what that means and why that's so important, and how to segment your field when you're doing your flight planning. So that way it works with the amount of chemical within, and you're strategically covering acre by acre or hectare by hectare. And we
Right.
teach you that process in depth in person in the training. So
Right.
other than that, I don't have anything else to add. Other, like Simon said, please, like, subscribe, turn on the alerts. We're going to be here each Tuesday, talking drones. So give us, come into the chat on the company. We're here for you. Give us a call, and we'll see you next week. Right?
Absolutely. Yeah. Thanks, John. We'll see you guys
Thank you.
next